Good news. It turns out that I suspected we had noise. I knew we had noise problems in the signal, and I was wondering if it was the bandwidth of the scope that was causing the noise problems. But it turns out that after some messing around, one theory was that the noise was attributable to ground noise. You know, the PCB has its own ground, and it's going to vary with the machinations of the circuitry there, and it's going to differ from the scope's ground, and that was indeed the case. So by grounding the probes to the motherboard ground, the PCB ground, it has really brought out the detail. It's got rid of most of the noise. There's still some ghost in there, but you can see discrete pixels on the Asteroids ship. It's also less fuzzy. You can actually see it. It was difficult to see in the other video. But this is true for all data now, so there is the potential to now apply maybe some filtering. So if we put a capacitor on the line, you know, on the output from the DAC, there's the potential now to smooth out some of these jaggers that we've been seeing and actually get smooth vector interpolation. And the critical question here is, will we be able to do that and without rounding the edges or clipping the lines, etc. You know, because it might screw the timing a little bit, but it's also going to soften the edges of any vectors, and hopefully there's some beam parking between vectors in order to give us some wiggle room to filter the signal. But that remains to be seen. But awesome development, right? We can zoom in here and see quite clearly discrete pixels everywhere in our supposedly vector signal. It's actually, this is a 1024 by 1024 10-bit DAC result, right? You know, the signal is analog output, but we've got 1024 discrete values output from a 10-bit DAC, and it results in pixelization. And the scope can pick it up, and I can see aliasing on the monitor. So if we filter this, we should be able to connect these dots basically, and obviously average the dot over time. Now the key problem with that is if there's not enough rest between vector segments, then there's not enough pause at the start and the end of both. In fact, we could potentially just see rocks being clipped and all sorts of nasties. Obviously we're not going to redesign the whole hardware, but there is the potential to make some improvements. And anyway, why not? Let's see what happens. I think Atari might have missed the trick when they built this thing, because a little capacitor, maybe they did do it, and maybe the capacitor's just gone on the board. I mean, that's the other possibility. You know, you want to filter these lines, you want to get smoothness out of even though if you get 1024 discrete positions, you want to get smooth interpolation. And if you have, if you can do that with the addition of a simple capacitor, then why wouldn't you? You know, because all you're going to lose is a little bit of time, I think, because you have to park the beam maybe a bit longer. But maybe they were already pushing the limits in terms of frame rate, etc. Difficult to tell, impossible to know. But yeah, potential. We've got a much crisper image when we zoom in. We've eliminated the ground noise, which was causing just fluctuations in the display. It's a lot more stable, and I can see discrete pixels. So good news. Next phase 2 is to maybe add a filter to the DAC output. Awesome.